I have been sneaking into the Passive House conference in Germany, and I've been listening into a few presentations, especially on the overheating part and all that stuff I've been teaching and calculating and finding over the time being here and thinking and looking into science and calculating. It's all correct. It has been proven with actual projects they have been doing. With the material we are giving you in the cooling part, you are really, really ahead of anybody else in the world, I would say, understanding the cooling issues in a passive house. Split system is the best way, like using an air recirculating approach is the best and most efficient way. Chilling ceilings, all that stuff works. But when we speak economical, then the economics go down. Obviously, that can all be done. But with that material we put together, that is far beyond what is normally taught and has been proven in practice from what I've been listening to now. So you're well prepared with that material. So that's good to know. And it's super interesting, the different communication, like the Europeans are so far more ahead of communication regarding energy efficiency and things like that. So wordings and bring it into an understandable level. That I find that as a teacher interesting from that point. We are still really behind here in Australia, but there is massive opportunities, and they are trying to, like, think about the Passive House standard. It's an open standard. Yeah, it's available for anybody. The software for it is a few hundred dollars. The 3D modeling is another few hundred, like $500. So for about $1,000, you're having a modeling software, a calculation sheet that is really giving you realistic results. Yeah, so in my opinion, this is the first step that we should do. And after that, we do all the political factors and lobby factors and all that stuff. So first we want to calculate the reality, and then we start messing up the reality by putting political factors on and lobby factors. They are wanted, guys. Like as a nation, as a government, you want to use these factors. You want to use political factors. You want to use, to some extent, lobby factors as a party to manipulate your voting. Like, it's just the way that business works. So you want to have that in there, but because of that, we never get a realistic result. And with lobby factors and political factors, we can encourage an industry to move into a direction. Yeah, so for example, in Europe, we still, I don't know how much it is in Australia, but in Europe, we're still giving 2 to 8 cents per kilowatt hour to fossil fuel industries. So they're having like substitution by 2 to 8 cents per kilowatt hour. And renewable energy, they have that as well to some extent, because we're having these schemes that you're getting more money for your kilowatt hour than you normally would pay when you're buying the kilowatt hour. So there's a little bit of substitution happening as well in that regards. Like, we were getting the first photovoltaic system we put on the roof, we nearly got $1 per kilowatt hour. Here, you're happy when you're getting 7 cents. Yeah, so we nearly get a $1 per kilowatt hour. That's 2004 with the first system we put on the roof. So this is the way that they were substituting renewables by actually giving the person that produces renewable energy more money than they actually would get by using the energy directly. So it was taking away the storage issue. So now it's moving away to reducing the energy, the payment for the kilowatt hour, and increasing the payment, the substitution for storage. Yeah, so it's a different process here in Australia. Profitable renewable energies, like speaking solar in particular, because of your sun hours. You have so much sun. Yeah, so I would say if they increase the return of investment to 15 cents per kilowatt hour, you will have a massive boom in the solar industry because of that. It's already economical to put it on, but if you would put that even up and double it from 7 cents to 15 cents, it would be really crazy. So So the Passive House Institute or the European Union is trying to implement the Passive House standard more and more into the national levels. Yes, so having them in there as a calculation approach. They looked as well at the big scale, like looking at 2050, 2070, and what do we need to do with our building stock and how is it impacting with the thermal insulation. So I found it super interesting, especially talking about the building stock. And maybe we have not stressed that enough yesterday. If you do it right. Yeah, if you do a thermal upgrade, don't put on a 20 millimeter thermal insulation, put your 60 millimeter, 80 millimeter, 100 millimeter of thermal insulation on it, depending on your climate, and not do half measures, because with a half measure step, there is no economical upgrade possible in a later stage. Yeah, so that's a bit the challenge that we're having. I found that really interesting. Then they were discussing the embodied energy a lot, and they showed thermal insulation and the embodied energy in the return of like the energy savings that they're having. It's like you're having this little slim sliver at the bottom that is embodied energy, and then you're having this massive bar of the energy you save because of using the thermal insulation. So yeah, the embodied energy is really something, especially speaking about thermal insulation, it's not important. So EPS, XPS, foam insulations, rock wool, fiberglass, all that stuff that have more embodied energy compared to a wood fiber also it's the right choice if it's the right material to use. So don't worry about embodied energy, especially with thermal insulation. Look at what is the right solution for your situation. We had that situation in Russia where putting fiber insulation on the wall would actually cause a condensation issue. Then we replaced it with a foam insulation. Now actually it worked. So in that case, foam insulation is really the best choice, just because of the vapor transport issues already. We know, for example, in climates like Sydney, Perth, Brisbane, like warm climates, where we have a more balanced climate. So in a cold climate, we over-design for the winter time. Yeah, we over-design we are designing for the winter time, and we're having a thermal difference of 40 Kelvin in the winter time. But now we're having only a 20 Kelvin difference in the summer time. So we completely over-design for the summertime. This is the reason why our buildings are normally not overheating in a cool tempered climate, because they're totally over-designed. Now in a climate like Sydney, where it's 20 Kelvins on both sides, we really need to understand the overheating better. And I'm convinced, and they're not there yet, I'm convinced we need to put in the heat capacity of materials. So it means, in other words, the thermal mass of our thermal insulation, to find out what's the thermal lag time. Yeah, so we can get away with a 120 millimeter stud in Perth as a thermal insulation if we're using wood fiber. But if you're using now a super light fiberglass with 15 kilos per cubic meter, then our temperature from the outside is traveling through that buildup in less than an hour. And now we're having inside a surface temperature of 32 degrees. And now that is radiating, or like we're feeling that thermal difference, and that's not comfortable. Soon we're putting now that wood fiber in there. Then it takes 5.6 hours until it comes through. And now with the time shift, we're having now already the cooling capacity with, for example, Perth Fremantle Doctor, open your windows and then getting the air through. So it's not any longer like when the solar radiation is highest, we're not having the highest temperature. It's normally in a slight time delay of an hour to 2 hours. So what does it mean when I have only 1 hour time delay of highest solar radiation hitting my wall, and now an hour later I have the highest temperature coming through the wall and the highest temperature outside? I have no chance of doing passive cooling, like passive measures, and it's uncomfortable. However, like I said before, and as well, that's not a common understanding of the cooling climate yet. I'm not worried about cooling at all. I'm not worried about the global warming from a living perspective when we speak about heat waves, because there's only a heat wave when the sun is shining. There's no other reason why it's getting hot. The only energy that we're getting to our planet is actually coming from the sun, and the only reason it's getting hotter is because more solar radiation hits the ground. When that is happening, my solar system on the roof is able to produce energy, and we can use that for cooling. So the cooling side, I'm not worried about it at all, as long as we're designing to something like passive house. And I think the 20 watts per meter square is a good measure from an economical point of view on the load side. Yeah, the demand side is a different one, but the load side, 20 watts per square meter. If you're designing your cooling system to 20 watts, I think you're really future safe and done a good job. And if then your calculations of the passive house standard cuts down to 12 watt, 13 watt, I wouldn't worry too much about it. Yeah, because your system can handle it, even if we have a heat island effect a bit more than we actually assumed. We can still handle it with the system. Yeah, so retrofit is something that we really need to tackle. In Australia, we expect by, what was it, 2050? I think it's 2050. I might be wrong. I'm quoting now from a study done here in Australia, and I think it was 2050. We expect that 60% of the buildings standing in the year 2050 have been built after 2019. That study was before the pandemic. That was even before 2019. It may have changed a little bit because of that extreme difference in history. Be even worse because people say, I don't want to live in the city any longer. I want to have my garden. I want to have more like this country living, and realizing they can have it because they can work from home and not driving into the city. So it might be even more. So the new build, what is standing by 2050, is expected to be more than 60% of the property out there. Yes, we need to tackle the building stock big time. However, because of the fast circles here in Australia, like the quick turnaround of the buildings, the new builds are the really important ones. So we need to make sure that all the new builds are built close to the passive house standard or better than the passive house standard. In my opinion, passive house standard is the worst standard that we can build to, but the only one that works. Like, it's the worst one that we can build to, but we can build better. Yeah, so we shouldn't go worse than passive house classic. We can go passive house plus, premium, plus energy houses, power stations, all that things, like making our houses power stations. I believe that's the right approach. And it has shown, like, again and again, that it's actually economical to do that in the long run, not in a day-to-day basis. We know that passive house costs us a coffee a day in the first year. So the additional financial burden is 1 coffee a day. So 1 less takeaway coffee a day would mean you are having now a family that can live healthy, sustainable, and you have a really good investment into your retirement. Good. That was now going all over the whole course material in a little bit crazy way. But so now you're coming to the end of your Passive House Designer course, guys. Yeah, so you have done the whole theory of it. Then we started to implement it on the economical side. Then we started to implement it into the retrofit side. And today we are now actually finally seeing the software.